Well, for now, let's get started. So, okay, new PRs this week. There is a new PR from Aaron85 that changes how the op queue works, and that makes me super nervous. But it sounds like he thinks that we can get better lock contention behavior with his changes, and then also maybe better performance. So I'm hoping that he can give us a lot of performance data on it before we merge, but we'll see. So right now, I think there's more work that needs to be done there. We've got an librd one. I think Jason is reviewing that. Needs QA. If I remember right, he thought it looked okay. More Crimson work, so performance improvements there. Those are coming in pretty regularly every week. And then this one I'm super excited about. In BlueStore, this is a new backend IO engine for the U-ring stuff that Jens Axbo merged into the kernel. This is all real new, but basically the idea is you're replacing libAO, and I believe that it eliminates some of the blocking behavior that libAO can see in like IO submit. And just generally seems like it's working much better. So some of the performance improvements there are substantial, assuming that this carries over. The tests were done on like a RAM disk, I think, and using some non-standard settings like smaller blob sizes and a smaller min-alloc size. But if that carries over to kind of NVMe, that this could be pretty substantial. And the big thing is that the performance improvements were in areas where I've seen kind of strange dips for us in the past, like 128K IOs for whatever reason previously have seemed to perform worse in some cases than smaller IOs. And here he's seeing a big improvement there. So this could be really nice. Could be substantial. I'm really excited about it. So let's see what else. What closed this week? Some Crimson stuff for debugging. This delete range thing for RocksDB, I wasn't actually paying too close of attention to what happened to that. I know that there were some concerns about it, but it's probably in the PR there. So Sage must have thought it was okay. Crimson performance test tools, so more stuff there. And then this whole space iterator work that Adam did, I think that must be merged now into some of his other PRs for the sharding work. So that just got closed. All right, and updated. I think the right around cache policy work for librd was not passing tests, so that needs to be figured out. New commits to this messenger IOPS work. That looks like it could be good. And this object store PR, I don't remember what that is. But I think Sage added it to testing, so that might merge soon. And okay, that's about it for this week. The discussion topics for this week. The priority cache manager PR that I submitted went through review, and I made some changes to it. I'm waiting for Patrick to be able to look at it again, but hopefully that will get merged soon. No performance improvements really there right yet, but that kind of further lays the framework for some other things, and then also for adding the memory target work to the other daemons. So that's just kind of in the works framework for that. I wanted to mention on the mailing list that there was a user who was seeing big heap memory usage in their OSD. They set the memory target to 4 megabytes, but the heap was actually about, or sorry, 4 GB, and the heap was about 6. So RSS usage was high too. That apparently was all in memory that was unmapped that the kernel had yet to reclaim. I had mentioned to them that they might want to disable transparent huge pages, but it sounds like as soon as they introduced memory pressure, the kernel did end up reclaiming it. So this is kind of one of these cases where we can't control the kernel. It will or won't reclaim memory as it sees fit. And in this case, I guess it just didn't do so until there was memory pressure. So yeah, unfortunately, it's kind of can be complicated for us when we try to convince users that it's okay that the process is really using 6 GB even if the target is 4, because the kernel could reclaim it, but just chooses not to. So the other thing I am working on right now is kind of since BlueStore was introduced, we have a situation, well, the common situation is that BlueStore nodes get double cached both in the RocksDB block cache and in BlueStore. And it really kind of is unfortunate because as soon as you start having cache misses in the node cache, you'll end up double caching everything. When people benchmark, they don't see that very often. They'll see if their data set's not super big or not big enough to cause cache misses, they'll end up with everything in the BlueStore node cache, and it works great and everything's really fast. But as soon as you start missing, then you'll start double populating, and then it gets bad. So my hope is that we can disable the block cache for the column families that store BlueStore nodes, and then avoid that kind of double caching entirely. So that's what I'm working on right now. I don't know if it will work or not, but I'm hopeful. I think that will be a big performance improvement when we don't have enough memory to cache everything. So that's about it for me. I don't see Kifu or Radek today, so maybe we won't get a CSAR update. Other than that, it's progressing rapidly, and performance already for reads is faster than stock Ceph, Ceph with BlueStore. It's not doing as much yet, but the results are really encouraging. So I think it's going to be good. And then Adam, not Adam Emerson, the other Adam, he's working on sharding still, but I'm not sure if he's quite got all of his performance data yet. So maybe next week we can get an update from him. And that's it for me. Anyone else have anything they would like to talk about this week?
Well, I think the C-Star work performance is really promising. I'm just curious what are they using as the backend right now for the object store?
It's I think it's the custom memstore work that they were doing. If I remember correctly. Let's
Cool,
see if Radek.
that sounds right.
Here is this is Radek's trace that he shared this morning. I don't know if it actually says in there what the object store backend was. The issue that he was running into this week actually was that they were limited on the client side by Rados Bench and didn't realize it at first. So they started using multiple Rados Bench processes, and that actually resulted in a somewhat substantial speed up. Yeah, I don't see if maybe I'm missing it, but I don't see the if that says what object store backend he was using. Well, anyway,
Yeah, I don't know that they've implemented anything other than memstore, so that's probably the one.
Yeah. Anything else, guys?
Mark, this is David Bite from SUSE. I'm new to
Yeah,
the
hi.
call. Um, and I'm not really a developer, but I'm here because I try to understand the deep technical details. Um, when you're talking about the double O node caching, what is the symptoms? What are the symptoms that uh, show up when that's happening? Are we talking like
So
the small IOs under 64K is where you see the drop off?
the gist of it is that the O node cache and RocksDB's block cache are kind of hierarchical in the way that BlueStore is designed. So if you have a cache miss on an O node in the BlueStore O node cache, like it's not in cache anymore, then it will try to read it from RocksDB, and that read will then potentially try to read it from the block hash. And if it's not in the block hash, it will actually go through and find whatever SST file it's in and read it from there. And then when that read happens, it will populate RocksDB's block cache with the block that read came from. And it will also populate then BlueStore's O-node cache. BlueStore will populate the O-node cache. We've discovered that you really kind of want those reads to happen from the BlueStore O-node cache when you're on really fast devices like NVMe. It's substantially faster than going through the whole decode process to fetch it from RocksDB itself. And even fetching it from the block hash in RocksDB isn't really that fast. It's okay, but it's not great. So I think what we really want is we want to be probably fetching OMAP data from the block cache, like caching it there, at least right now, and then certainly caching indexes and filters in RocksDB. If we have to do a read from disk, we don't want to be scanning at every level for where that key lives in all the different SST files. So we want the Bloom filters in cache. We want indexes in cache. Right now, we want OMAP in cache, but we don't necessarily want O-nodes in cache. We kind of want that to not pollute the block cache, and instead just cache those in the O-node cache. It can happen regardless of what the I/O size is. It's just if there's an O-node miss, then you're going to end up with the O-node read into both. Or sorry, the O-node read into the BlueStore O-node cache in the block that the O-node exists in, or the RocksDB representation of it. That block will get read into the block cache. Does that make sense?
Yeah, I think so. Thanks.
Cool. Yeah, no problem. I suspect that if I don't know for sure, but I suspect that if we stop caching those blocks in the RocksDB block cache, we're going to, one, see much better kind of memory fragmentation behavior in the OSD. Right now, the autotuner substantially shrinks the overall amount of memory for cache when the block cache and the O-node cache start competing with each other. But that's not a definite answer, but it kind of looks that way. And I think that both because of that and because we're not double caching, I think we're going to see a lot more O-nodes be able to be cached with the cache balancing behavior. I think overall it's just going to all behave a lot better. So we'll see, but that's kind of the hope right now.
Okay, that'll be interesting. To give it an idea of some of the stuff I do here at SUSE, I work in our alliances as the SES guy, the Ceph guy, and I've got this large cluster that I've got a bunch of SSDs and some P4800s that I'm doing testing against. So I'm looking at the tunings that make sense, and then trying to understand the odd behaviors I see sometimes. So that's why this is important to me.
Yeah. So with like P4800s and fast SSDs, probably what you'll want to kind of look at, I would think, is whether or not those P4800s, I assume you're using those for like the DB and write-ahead log? with like?
I've tried in that. I've also used them as the sole storage device. So
Okay,
as the OSD itself.
sure. Um, so my guess is that CPU usage, if you're just using the P4800, is going to kind of dominate since they're so fast. And that would be the bigger limitation you'd run into. If you're using them as like the DB wall and have another device for the block storage, then kind of the question would be whether or not eating the read, like letting the P4800 like service reads rather than like what then it'll be kind of a question of like, are you better optimizing for lower CPU usage, or better optimizing to like reduce reads and writes on the P4800? And I have no idea. Hopefully we'll find out. We'll be able to test that sooner because we don't have any right now in house, but we're getting some. So that'll be a really interesting question.
Absolutely.
Cool. Anything else, guys? All right, quick meeting. Hopefully we will have some updates on the C-Star work and Adam's charting work next week. I'll send out a notice again to the mailing list if I can schedule something. But otherwise, have a good week, guys. And there's a message here.
I just pasted the commit that adds the dummy object store for Crimson.
Oh,
Oh,
okay.
cool. I didn't see that.
Great.
It doesn't do much, but it's pretty simple so far.
Cool. All right. Well, have a good week, everybody.
Thanks.
Thanks, Mark. Bye-bye.
Thanks.
See ya.
Change time.